So in the transformer packet, number 48 should be 13 turns. I'll give you a second to get there. That's the one that has the measurements on the front. This one. It's just the taped up one, not the one with the graphics on it. No graphics on it. It's the one we were working out of yesterday. It's got, this is the page we had homework on. Haven't found that one? Okay. I'd grab you another one, but I think I only had 4 copies of that one. So anyway, 13 for number 48, yep. Number 49, 21 volts, 50, 3 volts, and 51. 27 turns, good. So for 52, resistance is directly proportional to length. 90 feet of wire is 0.6. 945 feet will be 6.3 ohms. Looks good. 53. The amount of charge a capacitor can hold is directly proportional to the surface area of the plates. If a 32 square millimeter capacitor can hold 4 volts, a 68 square millimeter can hold 8.5. Sounds about right.
How would you work out the squared units?
Okay, the squared is just a unit. It doesn't affect the numbers. So it is simply, you have 4 volts for 32 square meters. How much are you going to have for 68? Cross, multiply, and divide.
Okay.
If a wire has 40 feet, and it's 40 feet long, has a resistance of 0.2, how long is a piece of wire that allows 7 amps to flow when there's 4 volts? So this one, you've got to go through a couple of steps. You've got to do your 4 volts over 7 amps. Gives you 4/7 of an ohm. I'm going to leave it as a fraction because if I divide that out, it's like 0.51 or 571428, 57143, somewhere in there. So we're going to leave it as 4/7 of an ohm. So 40 feet has 0.2 ohms. How many feet has 4/7 of an ohm? So 40 times 4/7 divided by 0.2 is going to give us a fraction. 114 and 2/7. Or 114.285714286. Yes. Okay, so down on bottom, we have to convert the units. We had 8 ounces to 3 gallons. You want to know how many ounces that is to 3 quarts? Very good. Yeah, we have to convert the 3 gallons into 12 quarts. You cross, multiply, and divide. That is 2 ounces for 3 quarts. And 9 ounces for 3 gallons is how many ounces for 4 quarts? 3 ounces. Perfect. 40 miles in 1 hour is how many miles in 1 minute? 2 miles a minute. Perfect. 2 miles in 3 minutes, I should say. 2 pounds per gallon is how many ounces per quart? 5.3. Sounds about right to everybody? So you're going to take the 2 pounds, 3 gallons. We're trying to find ounces for 2 quarts. So we're going to convert everything into the smaller unit. So 2 pounds is going to become 32 ounces. 3 gallons is going to become 12 quarts. So 32 times 2 divided by 12. So 64 divided by 12 is 5 1/3. So then we've got 18 pounds per 6 feet. How many ounces per 3 inches? 12. And then 800 square feet for 3 gallons. How many square inches in 3 pints? 2,400? Okay, let's take a peek at that one. Let's make sure. That's what you got out of the 800 square feet? Okay. that doesn't sound too far off. To turn square feet into square inches, it is times 144, right? Because it's squared. So it's 800 times 144. Okay, so you get 115,200 square inches. Now our 3 gallons would be 12 quarts, which would be 24 pints. So we're going to take the 15,200 times 3 divided by 24, which is 114,400 square inches, which you had for your answer. So you were good. Okay. Enough of that packet. We'll put that one away. Excuse me. So, what we want to do today is we want to take a bit of review of percents and some applications of percents, variations of percents. Again, throwing in some of our other related review topics. A percent, to understand percent, you have to understand the meaning of the word percent. Percent's actually 2 words. Per, which means like miles per hour, miles per gallon, whatever. It means for each or out of. And cent, if you think of years in a century or cents in a dollar, it's 100. So if I have 84%, that literally means 84 out of 100. In fact, that's where the percent symbol came from, that we see like that. It actually is a generic symbol for a ratio. It's that easy to change a percent into a fraction. You just put it over 100. Now, of course, we're not going to leave it as 84 over 100. We're going to reduce it. Both of those can be divided by 2. Here's this 42 over 50. And then 2 again. 21 over 25. So 84% as a fraction becomes 21 over 25. It's a little more interesting, though, if we get into some more complex things. So if we have like 520%, that's still 520 over 100. To reduce that, first thing I would do is I'd take out the whole numbers, make it into a mixed number. 100 goes into 525 times with 20 left over. And then I would reduce the 20 over 100 by dividing both numbers by 20. So I still got the 5. 20 divided by 20 is 1. 100 divided by 20 is 5. So 5 1/5. But we can run into like 36 2/3%. How am I going to make that into a fraction? Well, still 36 2/3 over 100. But I have to reduce that somehow. I don't like having fractions within my fractions. Well, there's 2 ways we can go about it. One, we can get rid of the denominator, get rid of the fractions. Did you guys solve any equations with fractions in them last semester? Did you go through finding the common denominator, just multiplying the whole thing by the common denominator, get rid of it? Same type of deal here. My common denominator is going to be 3 because that's my only denominator. I just multiply the top and bottom by 3 and all my fractions go away. 100 times 3 is 300. 36 2/3 times 3 is 110. My fractions disappear. I can reduce that down. What I think is actually slightly easier, remember we've mentioned that a fraction and a division problem are kind of interchangeable. 36 2/3 over 100 can be thought of as 36 2/3 divided by 100. So you change 36 2/3 into an improper fraction. 36 times 3 is 108, plus 2 is 110. So that's 110 thirds. Make that 100 over 1. So instead of dividing by 100 over 1, you're going to multiply by the reciprocal, 1 over 100. which is 110 over 300. And now you're going to get the same answer you had up here, so we're going to reduce. They end in 0, so they can both be divided by 10. So you get 11/30ths, and that's where you have to stop. Or what if we have 56.25%? Well, that's 56.25 over 100. However, we do not like having decimals within our fractions either. How do I get rid of that decimal? Well, if you see that that's a 0.25 is 1/4, you can multiply by 4. But typically, it's not that simple. We have 2 decimal places here, right? So to move the decimal point over 2 spots, I'd have to multiply by 100. So I'm going to multiply the top and bottom by 100. So this becomes 5,625 over 10,000. Now I can reduce. And I'm sure that all of you can see that both of those can be divided by 625, right? You divide by 5 4 times and do the same thing. Which is going to give you 9 over 16. I'm just saving a little time. I want you guys to try a few here now in your notes quick. So 365%, 18 1/3%, and 62.5%. Turn those into fractions quick. Let's see how you did. I know some of you aren't quite done yet. So 365% becomes 3 13/20. Good. Anybody want to see how that one's done? Okay. So 365 over 100, right? Percent's always over 100. I take 100 out of 365 3 times with 65 left over. Then both the 65 and the 100 are divisible by 5. 65 divided by 5 is 13. 100 divided by 5 is 20. And the whole number of the 3 is still there. 18 1/3%. You still look confused. You got it? Or?
Yeah, no, it's
Okay. 18 1/3 is what? 11/60. Any questions on that one? We want to see how it's done. Yeah. So it's 18 1/3 over 100 again. Now, did you guys multiply by 3 or did you divide it out? By 3. So 100 times 3 is 300. 18 1/3 times 3. What you have to do is you have to change that to an improper fraction. So 18 times 3 here is 54, plus 1 is 55 over 3. Then you multiply by the 3 over 1, the 3's cancel out, so that's just 55. And now both of those can be divided by 5. That's 11 over 60. And finally, 62.5% is 5/8. You want to see how that one's done? Okay. So 62.5% is 62.5 over 100. Multiply by 10 on top and bottom to get rid of the decimal. So that's 625 over 1,000. And then reducing, they're both divisible by 5. They're both divisible by 25. They're actually both divisible by 125. Gives you 5/8. Because there's a decimal within my fraction, I don't want that decimal there. So to get rid of the decimal, I've got to move it over. So multiplying by 10. The shortcut is I can move the decimal over here. To have to take this decimal, move it over, and add a 0. Kind of like when you're dividing with decimals. But multiplying by 10 is really what's happening. That's the mechanism that makes it happen. So now converting our percents into decimals is a little simpler. You know, we had our 84%, which we said meant 84 out of 100. To turn that into turn a fraction into a decimal, we just divide the numerator divided by the denominator. 84 divided by 100, which is 0.84. So since every percent is out of 100, turning it into a decimal is just going to be dividing by 100. And we divide by 100, the shortcut, of course, is the decimal point just goes 2 spots to the left. So if I have 31% as a decimal, it becomes 0.31. I want you guys to try some in your notes. See how much you guys remember of percents and these before we go over them. So I'm going to have you do 29%, 430%, 8%, 70%, and 4.9%. Convert those into decimals. Okay, so we'll go through what you've got so far. 29% becomes what is the decimal? 0.29. 430%, 4.3, just moving it over 2 spots. 8%, 0.08. Good, moving it 2 spots, you got to add that 0. 70%, 0.7. 4.9%, 0.049. Good. Any questions on those? Now, of course, if we have a decimal and we want to convert it into a percent, like 0.36, we want to turn it into a percent. A decimal is technically what we call a proportion. It's out of 1. 0.36 is our proportion of the whole, our proportion out of 1. Since a percent is out of 100, we have to convert this like we would a fraction. We're multiplying by 100 on the top and bottom. So when you multiply a number by 100, the shortcut, of course, is the decimal point moves to the right 2 spots. So 0.36 is a decimal, is 36 out of 100, or 36%. So 0.7 would become what percent? 70%. 0.91 is going to become what percent? 91%. 2.5 is going to become 250%. 0.092 9.2%. And finally, turning our fractions back into percents. We'll start out with one that everybody knows. 3/4 is, of course, what percent? 75%. If we didn't know that, there's a couple of methods we could use. We could have turned it into a decimal. 3 divided by 4 is 0.75. And then move the decimal point. But not all fractions turn into nice, neat little decimals. So what we can do is we can think of 3/4 as being 3 out of 4. And a percent, of course, is always out of 100. And it's a proportion. So you solve 3 times 100 divided by 4 is 75. So it's 75 out of 100, or 75%. If you had 2/5, what's that going to become as a percent? 40 out of 100, or 40%. Perfect. So I'm not going to spend any more time on just converting with them. I want to jump into some calculations. How much did you guys do on percents last semester? Did you guys do much at all, or not a whole lot? Okay, so we'll go through a little bit here, and if we have to, we can spend more time on it again tomorrow. So we use that proportion, and I was just illustrate some problems here. Let's do this. Let's say I ask you, blank is 70% of 90. To deal with percents, I kind of use this proportion that I used here for dealing with fractions. 70%, and I always start with the percent. 70% is 70 out of 100. Once you have that, all that a percent problem becomes is matching up stuff on the other side of that proportion, on the other ratio. There's 2 other numbers in the problem. Here, the missing number and the 90. One of them has to match up with the 70. One of them has to match up with the 100. If you look at the wording here, blank is 70%. Kind of implies that the blank matches up with the 70. Of 90, if you read that as out of 90, implies that the 90 has to go on bottom. So that both kind of match up. So I cross multiply and divide. 70 times 90 is 6,300. Divided by 100 is 63. So 63 is 70% of 90. You might have blank is 130% of 40. Tell me how to set this one up. 130 over 100, good. X over 40, good, or a missing number over 40. You cross multiply and divide, you should get 52. You guys good with cross multiplying and dividing? We've done enough of it. You're okay with it. Okay, so I'm not going to do the 130 times 40 is 5,200, and I'm just going to say cross multiply and divide and get the result. This one is worded quite differently, but it's actually the same type of problem. 30% is there, so we're going to start with 30 over 100. Of 20, if I think of that as out of 20 again, implies the 20 has to go on bottom. Is blank. 30% is blank, so the blank matches up with the 30. Cross multiply and divide again to get 6. 30% of 20 is 6. So all 3 of those first ones have been kind of the same form. Let's change it up just a little bit. 42 is 60% of blank. So we're going to start out with our percent again. 60% is 60 out of 100. But now it's the 42 is 60. The 42 matches up with the 60. Think of blank. If you think of it as out of blank, implies the missing number is on bottom. So you cross multiply and divide. 100 times 42 divided by 60 is 70. So 42 is 60% of 70. So 20% of blank is 28. So again, we have the percent. 20% is 20 over 100. Of blank, if we read that as out of blank, implies that that missing number goes on bottom. 20% is 28, so the 28 goes with the 20. Now we cross multiply and divide. 100 times 28 divided by 20 is 140. So 20% of 140 is 28. We can run into something like this. 51 is blank percent of 170. Now, I said before we always start with a percent, but this problem doesn't have the percent. I am still going to start with it. This is blank over 100 for my missing percent. Now, 51 is blank percent. It implies the 51 goes with that missing percent. Of 171, or out of 170, I should say, implies the 170 is on bottom. And we still cross multiply and divide. 100 times 50 divided by 170 is 30. 51 is 30% of 170. Or blank percent of 90 is 54. So again, we're missing the percent. Blank over 100. Of 90, if I read it as out of 90, implies the 90 goes on bottom. 54 has to go on top. Cross multiply and divide to get 60%. I like the proportion because the proportion is always the same calculation. It's just a matter of lining stuff up. It's always going to be cross multiply and divide. Now, you might be cross multiplying in a different direction or whatever, but it's always cross multiply and divide. Some of you may have been taught something called the rate method of percents. In the rate method of percents, you take your percent and you turn it into a rate or a decimal. So 70% is 0.7. And here you would take the 90 times 0.7 to get 63, which is your answer. Same here. 130% is 1.3. You take your number of 40 times 1.3 gives you 52, which is your answer. Now that may seem kind of easy right there, and it is for some of these problems. The problem with the rate method is it's not always that straightforward. Here, we've got 60%, which is 0.6, but it's not 42 times 0.6, it's 42 divided by 0.6 to get 7. Same here. This would be 28 divided by 20% is 0.2 to give you the 140. So you have to, if you use that rate method, you have to know when do I multiply by that decimal, when do I divide by that decimal. And there's even the third type, like these, where I'm missing the percent, where I have to take the number, divide it out. 51 divided by 170 is 0.3, and then move the decimal to make it a percent. Now, I'll be honest with you, the rate method is how I was taught, and that's how I still do it in my head because I can do it very quickly. But I do see a lot more mistakes made when people try to use the rate method. In the next couple of days, we'll talk about percent increase and stuff like that, percent decrease. When we get into that, I see a lot more mistakes made if people use the rate method. So what are some things that we'll use this for? Well, for you guys, it gets used quite a bit is tolerances. You might have a resistor that's rated as 2.4 kilo ohms plus or minus 20%. Well, what's the actual range of that? Well, 2.4 kilo ohms, of course, is 2,400 ohms. Then you have to find 20%. So 20 over 100 of the 2,400. Ends up being 480 ohms when you cross multiply and divide. So that's really 2,400 ohms plus or minus 480 ohms. a lot of your systems run at 70% of peak. Like AC power, actually RMS is really 71% of peak, 70.7% of peak. But if your system's running at 70% of peak, you have a generator that's 4,000 watt peak. What can it maintain over the long haul? How many watts can it maintain for long term? Well, 70% of 4,000 watts. You cross multiply and divide, you get 2,800 watts is what you can have as a continuous drain on that generator. Now I'm going to show you, when we get into word problems, that's why the ratio, the proportion method really works for me. Because let's say we have a company claims, let's say PDM Corp estimates monthly profit as 12% of gross sales. Find gross sales for a month where profits are estimated at $374,400. So in these problems, if you have a percent, we start with it. 12% is 12 out of 100. And we have to ask ourselves what each of these stands for. Now the 100 stands for the whole thing, or what's often called a base amount. That base amount means that's what we're basing things off of. That's what we're starting with. That's the complete thing. The 12 is a portion or a piece of that whole amount that we are focusing on. So in this problem, we have two things here. We have estimated monthly profit and we have gross sales. Which one of those is the piece of the other? That's the focal point. Well, yeah, monthly profit is 12% out of the gross sales. Excuse me. So the 12 here represents the monthly profit. The 100% represents the gross sales. So when I go to set up the other half of this proportion, the number that goes on top has to be monthly profit. The number that goes on bottom has to be gross sales. I have the 374,400. Is that profit or sales? It's profit. Estimated profit. So 374,400 goes on the top of that ratio. So now we're going to calculate cross multiplying and dividing. What is that? 3,120,000, is that right? Okay. So that is our estimated, or that is our gross sales for that month. Okay, I've got some packets I'm going to give you here. Actually, I believe one of them is already in the packets you already have. We did Unit 29 yesterday, Unit 33 today in that packet. I'm going to double check and make sure that is in there. Okay, then in your other packet, it's page 255 to 256, 1 through 12. So in the Unit 33, you can just do the odds if you prefer. The other one, I'll have you do all of them 1 through 12. So you found Unit 33 in the one packet, then the other packet's the one that's got the big 12 on the front. We'll talk more about percents and probably parts per million and stuff like that tomorrow. In the 12 packet, page 255 and 256, 1 through 12. Got a little